Alright guys, in today's video we're going to be looking at something we ran into during the recent polar vortex a few months ago, and that's an engine block heater that's inoperative on this 6.5 liter diesel engine. Now somewhere on all of these 6.5 liter diesels, for the years and the video title, you're going to find an AC plug. In this case the owner just kind of keeps it right here. It might be on yours coming out the front bumper nostril, or it might still be stowed down here below the ABS unit, but somewhere there's going to be an actual AC plug, and that's one of the first things we're going to go diagnose. The problem is either in the plug or the element that's inside or installed into the engine block. This one's a 1999 Chevrolet Suburban, but for the video title, the model years I put there and the detail in the description, it'll apply to all of them. Alright, next you're going to want to drop down on the driver's side wheel well and this upper A-arm dust shield. You want to get a trim tool and work these little fir tree clips out without tearing up the shield. If yours is broken or you're missing these clips, I'll put something in the video description part number wise where you can get that corrected. Alright, fold this out of the way. And then what we're going to be looking for is, if we zoom in right there, that orange connector right there, that's the other end of this power cord that's going into the engine block heater. Let's see if we can get in there a little closer and you can see an actual view of this guy underneath the exhaust manifold. Maybe it's a little better view, guys. We zoom in a little bit more. So this plugs into the brass unit. You can see it's kind of some green tarnish on it that's friction fit into the block itself. So we're going to unplug this guy, and I'm going to get a voltmeter, and we're going to do some resistance measurements on the cord and on the element itself. Alright guys, I'm just going to reach my hand up from underneath. This is just a press-in fit. There's no retainer or anything. Just going to kind of wiggle it off. Just like that. You can see it's got 3 prongs on it to match the AC outlet. The one at the bottom's a ground, and then you've got a hot and a neutral. I pull this guy down a little bit. You can actually see the element, and you've got 3 prongs in the base of the element as well. Alright, so we've just got a multimeter, and right now it's set for a continuity test. So if there's ever a connection, it's going to tone out and beep. I've dropped the AC end of this cord down where we can bring it over here. And then here's the element end. So what we're going to do for these tests, we're just going to start first seeing, is there a break on any of these 3 wires? So inserting this guy into the ground. Bunch of crud in there for one thing. I don't get a reading on that. Might have found the problem right off the bat. Let's check these other ones. This guy here. If I can just keep it steady. So this one is not broken. But it's not a good connection either. A lot of tarnish on the brass. Got to kind of scratch it. Yeah. Alright, so that's not broken. So one of these is hot and one of them is neutral. Trying to just kind of scratch the brass a little bit here. Nothing. Not getting anything on this one either. So I think what we're looking at here is just a bad cord. So this guy we got continuity, but it's kind of half-ass. The ground we got nothing. And the other side of the alternating current we got nothing. Alright, so it's a bad cord for one thing. Looking inside here, we zoom in, Let me get this where you guys can see in here. All right, so it's a lot of green oxidation, corrosion on this. So the cord itself is definitely one problem. Now we got to go test the element while we're down here, because it could be that they're both bad, right? But the cord at least definitely needs to be replaced. So let's go take a look at testing the element. It's going to be very similar. I'm going to come in from underneath, and I'm going to try to touch these two leads to the two primary element terminals, and we should have a complete circuit there, because when you flow electricity through those two terminals, the element's on the other side immersed in the Dexcool coolant, and it heats it up. So there should not be a break there. So let me get underneath and see if I can do that measurement. All right, guys, so if you can see zoomed in here, I'm touching one side of the element, and now I'm going to come in with the probe on the other side. Thought I heard something there. All right. All right, so we got tone. All right. So guys, doing continuity is one test, but that doesn't mean that the thing is good, the element's good. We now got to come in here. I can just barely see this guy, and I got to go do a resistance test. All right, so we change the meter to ohms, and if I can get it where it doesn't move, I'll ask the camera person to show you what the reading is. It should stabilize now because I'm not moving anymore. Whoops. You got to move quick here, though, because I can't hold it very long. All right, so now we can get a reading off of it. And I'm waiting for a signal of what the reading is. It looks like it's less than 30 ohms. If it's less than 30 ohms, it's good. So we're only having to replace the cable. So the element itself is okay. So all we need here is a new cable to repair this problem. So let me slide out here and I'll show you what we're going to do to replace that. All right, guys, to get this cable out, we got to remove two 13mm fasteners securing a bracket. First one's right down here. Right there. All right, so that guy right there. We got to get him off first. This is an awkward angle because I'm trying to have you guys be able to see. All right, so we can see that the bracket is turning on us. So I'm going to have to go through the wheel well and kind of hold it. So I might not be able to show you guys that because that's going to be a two-person job there. But you get the idea. One is there. Get this guy loose. I'll show you the second one. Come on. All right. The second one's up by the radiator. So if we come up closer to the front, the other one is right here, conveniently obstructed by this power steering hose. Let me see if I can move the flashlight a little bit out of the way so it doesn't present as much glare. And if we zoom in, it's this guy right here. You can just kind of see right there on the edge. And so again, nothing to see here. So we're going to need to take those two 13mm nuts off, and then we can lift the bracket that's holding this engine block heater AC electrical harness in place. All right, taking a quick look at the service manual for this procedure. Coolant heater cord replacement. So the nuts and washers retaining the clip to the studs that we were talking about looks like this. So they got that stud that we saw. There's the bracket that's crimping the cord. Then there's a washer, and then there's a nut. And there's one towards the back, and there's one towards the front that's obstructed by the power steering pipe. And so let's see. So they tell you, so this is on the 7.4 gas engine, so we can skip that. It's one of these older manuals where they just kind of combine everything together. All right, so they're telling you that you want to apply dielectric grease to the front connector before you plug it in. That's to keep water from getting in there. routed along the heater hose. We can skip this comment because it's for the 7.4. Put those clips back into place, and then this is what we want. Those 13 millimeter nuts on those studs, they get tightened to 6 foot-pounds. So they're not very tight at all. Just the problem we had on ours is obviously that we've got a lot of corrosion. Actually, looking at this might be for the 7.4. Let's see. Tighten the bolt retaining engine coolant heater bracket to the engine. Yeah, this isn't ours. This is ours. This is ours down here. 106 inch-pounds for the 6.5 liter diesel. So those two nuts are going to be to 106 inch-pounds, and that's 1 and 2, just like they show here. That's the one in the front. That's the one in the back. Now, if you end up finding that the element has to be replaced, they go over that too. So coolant heater replacement, you got to drain the coolant before you do this. They give you some tips about orientation of this. The new part will have some more detailed instructions than this. Just kind of leave that there. You guys can read it on your own. Basically, you're going to tippy tap on these bosses that you see to get the seal broke loose from the block, and then you should be able to work it out with pliers by grasping onto the housing of where the plug goes. And then you got to clean the bore hole in the block, get rid of any burrs, rough spots, paint, anything else that needs to be bare steel. And then they tell you to coat the O-ring with a water-resistant high-temperature grease. This is long discontinued part, and actually, I'm very surprised. This is actually a petroleum-based product back then, which I would expect to attack the O-ring. Nowadays, I would just use silicone. Silicone grease is what I would put in here. And then they show you here, there's kind of like the O-ring. This is the block. This is the outer boss area. There's some wings. I'll show you what a new one looks like. When you tighten this screw, it pulls this down. These wings end up pushing against the inside of the block, and that's what holds it nice and tight, like you see in this picture here. And then if you do end up installing an OEM one, 18 inch-pounds is the torque on that center bolt that does that tightening. All right, guys, these nuts, these 213 nuts are pretty well rusted on here. So even though we've tried some blaster and everything else, I haven't been able to get them to budge. So I'm going to instead see if we can coax the wire out of the bracket instead. So it looks like it's just crimped onto the wire. It's plastic coated to avoid a short. Just using a very stout Lisle small pry bar for this type of job. Let's see if we can get this open without it breaking. It opened up a little bit. And there we go. All right, that one's out. Let's see if I can do the same thing on the front one. Goes a little bit. So glad we have the power steering pipe right here where it can be in its most inconvenient location. All right, got that one off too. Now we can fish it out. All right, I'm just going to use some emery cloth on this plug one more time. I've also already, before we started filming, used it on the plug that goes in the element. So now we don't have any oxidation problem. All right, so even touching nice shiny brass, we still don't have any continuity on that one. We got good continuity on that one now. And then getting a closer look, this particular one, the ground one doesn't actually have anything in it. And I guess that kind of makes sense. But it looks like it's just plastic all the way down. So I'm going to take one more shot because maybe I'm mistaken. I don't know. It looks like it's all plastic. I can't see any. Well, maybe there's metal in there. I guess there's just so much crud. Let's just do a quick check then. If we were to shiny up our ground, and we were to check if we have continuity to the ground, so there is metal in there, so I take that back. There is a ground, but we're not getting anything. So this cable, this power cable here is shot in two ways. You know, I thought maybe where it was on those brackets, maybe, you know, it got crimped inside. It's really hard to say. You know, that's one place where the bracket was crimping it, and then the bracket was crimping it here. But there's no physical damage to this cable, so I have no explanation as to why two of the wires are obviously broken. But that's why it's not passing the test. All right, so what would you replace this with? Well, let me get some of this cleaned up and I'll show you. All right, since we're just replacing the cable, it's going to be a GM 1573 7616. This is just the cable, or just the cord, right? And it's going to look identical to the one we took off. It's going to have the heat shielding. It's going to have the same shaped prong. And then we're just going to have to cut this little storage zip tie. It's just there for stowage. And it's going to have the same end on like that. Well, what if, now we can see here it also has, you know, all new brackets here, at least on one of them. So we may have to, yeah, we're going to have to get that out of there because like we couldn't get those out. What if we had to replace the element as well? Well, I had one of those on hand just in case that was the problem. This kit is a 1234 3981, and what's inside is an element and a cable. So this is what is sitting inside the engine block. So we can see it, you know, sitting like that. And this guy is, well, in our case, it's plugged in like that, right? These OEM ones are nice because they've got these three big bosses on the brass, so you can get something to tap them loose. When you tighten up this screw here in the middle, these wings expand as this guy gets drawn in, and that's what holds it up against the block, and then it seals with this O-ring. You loosen this up, what tends to happen is this O-ring fuses to the engine block, and then you got to get it loose, and so you can tap, tap, tap on these bosses to work back and forth until it loosens up enough. You notice that they also protrude beyond the edge. So it makes a nice point to get a pry bar in once you get them loose. And that's how you can get this thing out of there. The one that's included in the kit is a little bit different shape, right? It's kind of like at a 90-degree angle. So this is like a later design. I preferred what we had because it's just a pita to get in there in the first place. So this one matches what we had. We could have just as easily used this one if we had to do that kit. Both these parts are discontinued by GM for like a long time, so they're really hard to find. They can be an Easter egg hunt. I'll put a company, an aftermarket company, it makes a kit very similar to this. They may even have been one of the suppliers to GM. I don't know. It looks very similar with those bosses I showed you. I'll put all of these part numbers in the video description. So what we're going to do now is just reverse what we did. But before I do, let's repeat that test. So I'm going to go grab our ohm meter, and we'll repeat the tests on the new cord, and even though we're not using it, on a brand new element, just to show you what those values should be. All right, so let's repeat the tests we did earlier in the video. we got the meter set in continuity mode. So it's going to beep when it finds a path. Let's take our new cable, new cord rather. Get this little weatherproof thing off of there. And now let's verify that all three of these tone out. There's that one. There's that one. And then ground. So all three tone out. So that means there's no break in the cable, the new cable. Now let me set it to ohms. Actually, I'm going to show you one other test we didn't do. If we had passed that test with the old cable, I next would have done this to make sure that hot and neutral are not connected to each other. And then make sure that hot is not connected to ground and that neutral is not connected to ground. That would have been another test to check for shorts. So this cable, as we should expect, is fine and ready to install. Now, the resistance measurement on the element. So we'll set this guy to ohms. See if I can get it over here where you can see both the tool and the part. And so on these two, whoops, yeah. You gotta keep this stable, and you gotta not let it touch the shell, the brass shell. So we can see a brand new one out of the box is around 25 ohms. And our used one, we were reading, I think, 28, 29 ohms or so, maybe 30. So it's 20 some odd years old, the one that's in this truck. So that's to be expected. There's probably some internal, tarnishing on the element, but it's still good. So all we needed was a new cord. So now we're going to go back and reinstall this, and since I need to take this one off, you can see what I was doing a little better underneath. So this guy is plastic coated, because if there was a problem here, you don't want this AC power to end up hitting the frame of the truck. So what I was doing is I was coming under here and I was prying this up. It's a little bit easier to do when it's got a bolt and a nut holding it down than I'm trying to do loose right here, but that's all I was doing. And so we're going to have to do that same thing here. I'm trying to just very carefully do that here where I don't, crimp this new cable. So I'm actually going to probably have to bolt this thing down on the vise, and then I'll be able to open this up. All right, so with that opened up, then we can get this guy out. So we're going to put this end on that aft crimp, or that aft piece, because that's where it's already been squeezed. Now when we go to squeeze this, you don't want to take a metal tool or anything because it'll cut through this plastic coating. We're going to grab a plastic dowel or something of that nature and tap it down that way. All right, let's work this original section that was crimped back in. Let's see, it was right there to right there. All right, now we just got to get a tool to squeeze this down. Right, the tool I'm going to try to use are some plastic jawed pliers. And that worked out perfect. All right, I don't know if we'll be able to get these in up front where the power steering hose is, but we'll give it a shot. Let's route this back up this way. Actually, let's route it under these battery cables. Okay, and then we want to route it under this bracket, get it crimped in there. Okay. don't know if you guys can see, but you gotta take my word for it. She's where she's supposed to be. I'm just trying to see if we have the right amount of slack based on the old one. I think we do. Just gotta get the flashlight out of the way, get it away from the brake lines. All right, I won't be able to get the pliers in here for sure. So that's where a plastic rod or dowel type tool, or maybe even a very small piece of PVC pipe. Let me see what I got. All right, what we're going to do is we're going to take a little plastic cover and we're going to put it on the end of this 3/8 extension. So that's going to be plastic to plastic. It's going to prevent any damage. And we're going to route this guy down right in between this axle vent hose and the power steering line right there. And then we're going to give a tippy tap with a rubber mallet. And we're going to slip and do it all over again. If we're lucky. Yeah, didn't close it enough to prevent pushing it in. Let's try this again. So almost got it that time. It's just really slippery because when we were trying to get the nut off, we liberally doused this with some penetrating oil. It's just all over the place still. I think a couple more taps like that will be good. Perfect. Give you guys a couple of shots from this view too, so you can kind of see what I'm doing. Just trying to get that plastic bracket crimped back down without scratching or scraping the coating. Looks good. Maybe one more on the end. Good. All right, let's go back underneath and reconnect it to the element. All right, we need to replace the wire loom. The new one didn't come with any, and our old one is too short to reuse. So we'll develop the approximate length and run this on our replacement cord. Kind of follow this guy down. You can see we put the new loom in between. I don't know if you can make this out, but you certainly should be able to see the new loom. It's the shiniest one in between these two brackets. We waited until we had everything crimped down to insert that. Had to trim off a little bit, maybe 1/8 of an inch to get it to fit. All right, before I go underneath and plug this back into the old element, this new cord, we're going to waterproof it with some AC Delco dielectric grease. It's an AC Delco 104064 or a GM 1234 5579. Like all these other parts, I'll put a link down in the description. We're just going to take a very little bit of this. This is just to prevent water intrusion that gets splashed up around this element from getting in and reaching the brass on these connections. That's all we need to do, is just around the plug itself. The hardest thing is we got to keep it from getting all dirty, so I'm trying to let it sit somewhere where I can put the cap back on this stuff. And then I'm going to route this in like that, and then I'm going to come in from underneath and go grab it. All right. This is like our last step, guys. Gonna kind of try to bend her around. Since she's new, she doesn't like this orientation. tight fit. There we go. Make sure that's fully seated. And we'll kind of curve this away a little bit. Get as far from the exhaust manifold as we can. All this silver tape you see on it is to protect it from the exhaust heat, but you don't want to have it actually laying up against it. And I just want to make sure one more time that I've got this thing all the way in there. I don't want any water getting in there and causing the same kind of corrosion we saw before. All right, that part's done now. All right, guys, are we done? We're all cleaned up and buttoned up, but we're not quite done. I'm going to take our plug out of its home here. I want to make sure I routed this correctly. Yep. And we're going, even though we diagnosed this cord as defective and replaced it, and we did a diagnosis on the heater element, we still need to test it. So how are we going to test it? All right, so we're going to test that we get the expected amperage draw out of this element with this new cord, and I'll show you how you figure out what that should be. So I've got an extension cord here that's hot, as evidenced by the light, and I'm going to bring over our voltmeter again, and we're going to set it to measure AC this time. The first thing we want to see is, what are we getting out of the AC? You know, is it 110? Is it 120? Is it 122, right? It can vary depending on your area. All right, so I'm getting 125.7. 125.7 volts AC. The other piece of information we need to do this calculation is the casting on the front of the element that we have in the block. All of these GM OEM elements are going to be 600 watts. If we zoom in here, we can see that the brass casting says 600 watts. Aftermarket ones may say 1,000, but this GM one is 600. And so we're going to do a little bit of Ohm's law math to tell what this test should be. So we're going to grab a calculator, and we're going to take the 600 watts, and we're going to divide it by the 125.7 volts, and we're going to get 4.77 or 4.8. So what that's telling us is we should get somewhere in the neighborhood of 4.8 amps. It won't be exactly, might be a little less, might be a little more, but that's the neighborhood, somewhere less than 5 amps. So how are we going to measure the amperage? All right, so what we're going to do to measure the amperage, since this is alternating current, we're going to need a tool to break this up so that we can do that. And I'm going to use a tool here from Klein, the 69409 tool. What that does is that divides the hot and the neutral up so that we can come in with an amp clamp and measure the current draw. Now, there's a lot of different ways you can do this. You know, you can use a kilowatt meter or something like that, but this is what I'm going to be using. This particular tool is rated to a maximum of 15 amps, and it multiplies the result by 10. So if we're expecting to get in the neighborhood of 5 amps, we're going to need the amp meter set for around 50, right? So it doesn't have a 50 amp setting, but it has a 100 amp setting. So we're going to set it for 100 amps. And now it's not very cold out today. It's only in the high 50s. So we're not going to leave this plugged in very long, because that's one way you can burn these elements out. So we're just going to plug this guy in, and we're going to see if it stabilizes and what we read. So right now you can see we're reading 46.3 amps, 46.2 amps, and it's holding nice and steady. So that's all I want to see, is that it's holding steady and it's drawing current, 46.2. So I'm going to go ahead and pull this off, and then since it's a 10x setup, if we find our calculator again, we can take our 46.2 divided by 10, real simple, we're getting 4.62 amps. So this element is in fact good. So we've done the test to verify that the repair is good, and we can rest assured that when the owner tries this on the next polar vortex, this will be ready for them to use. I would store this with this cap in this direction if you use in this particular spot, because it's not very waterproof, and water can get under here and cause the tarnish and corrosion on the plug that we saw on the original one. But we're otherwise done with this repair. Now, just a couple of words about this option. Every 6.5 liter diesel engine from GM for the years this video covers will have included one of these coolant heaters. GM recommends that you use it whenever the temperature gets down to 0 degrees Fahrenheit. What I would tell you is it's helpful to use it anytime it gets down below 15 degrees, but I would recommend you don't use it unless it gets that cold. You want to run it for a very short period of time just to warm the coolant up, somewhere in the neighborhood of 45 minutes to an hour. You don't want to leave something like this on overnight. That's another reason that can shorten the life and burn it out prematurely. This particular one, I'm quite confident to the owner's recollection that it's probably been in here for over 20 years and it's still working fine. So if you got questions or comments about the testing we did or the repair we did, go ahead and leave it below. I'll try to help you. If you found this video useful and it helped you get your heater working and ready for the next winter, I'd appreciate you paying it forward by hitting that like button. And as always, thanks for watching.